we have a basic idea of what is domain and range, and we have done some problems related to that. Now we'll discuss the domain and range of trigonometric functions. Now, before moving on to these type of functions, trigonometric, exponential, I'll first clear one thing, which is transcendental functions. Now these are the functions which are not algebraic. Algebraic are known as transcendental functions. So the examples of transcendental functions are trigonometric functions. Next is logarithmic functions, and it can also be exponential function. So these are the three basic types of transcendental functions which we are going to discuss. So the first of them is trigonometric functions. Okay, so I am going to use one specific way to teach you all these functions. That first I am going to clear the concept, and then I'll give you, at the end of the video, I'll give you some questions to solve. Okay, I'll not give you the solutions for like 5 minutes, and then you can solve it, and then you can match the answers with the board. So first of all, we'll start with the trigonometric functions. So guys, you must have studied about the trigonometric ratios. So you must know that there are six basic trigonometric ratios, or which we call as T ratios. First one is sin theta, cos theta, tan theta, then cot theta, cosec theta, and sec theta. Now these are the T ratios, trigonometric ratios. Now when we say that y is equal to sin x, this will mean that y is a function in x. Y is a trigonometric function in x. Now this y is equal to sin x will become a trigonometric function. Now this was a trigonometric ratio. We can write it as a function like this. Now this can also be written as fx is equal to sin of x. Similarly, fx is equal to cos of x. So we'll try to see the domain and the range of all of these functions. So I'll make a table for you. Okay, and on the right hand side, I'll do all the calculations. So just see, the first function is, so here I'll write the functions, their domain, and then their range. So let's start with y is equal to, or fx is equal to sin x. Now guys, the number of values, the domain is all the possible values which x can attain, or all the allowed values of x. Now there is no restriction on x. Here x can attain all the values, therefore the domain here will be all real numbers, or we can say that the domain is equal to R here, right? But we know that since the value of the maximum value of sin x is equal to 1 and the minimum value is equal to -1, therefore the range of this function fx is equal to sin x will be equal to -1 to +1, and this -1 and +1 both are included. Okay, so -1 and +1 both are included. So this is the domain and the range of fx is equal to sin x. Now guys, see, the domain is the list of all the allowed values. Okay, so this is the list of allowed values, and this will be the outcomes, or you can say the value of function. These are the values of variables, and these are the values of functions. Okay, so the second one is fx is equal to cos x. So this is similar. Okay, no doubt should be there that all the real values are allowed for fx is equal to cos x, and the range will also be -1 to 1 only. Okay, so for fx is equal to sin x and cos x, we'll be seeing that the domain of both the functions is R, and the range of both the functions is -1 to 1, where -1 and 1 are both included. Guys, when is this becoming 1? This will be 1 at pi by 2. Only pi by 2. Now this value, the sin x will be equal to 1 at x is equal to pi by 2. Similarly, x is equal to 3 pi by 2. Okay. Similarly, you'll go on. Okay. Will it be equal to 1 at 3 pi by 2? This is wrong. Okay. Sin x will be equal to -1 here. So we can say that it will take its extreme values at odd integral values of pi by 2. Odd integrals multiples of pi by 2. So for pi by 2, 3 pi by 2, 5 pi by 2, it will have the extreme values which are +1 and -1. Okay. Similarly, cos x is equal to 1 is only possible at x is equal to 0, or at x is equal to 0, this will become cos 0, and cos 0 is nothing but 1. And cos 180 will be equal to -1. So that is all about trigonometry. We're just seeing the domain and the range of these functions. Now let's see fx is equal to tan x. Now this is a little tricky. Fx is equal to tan x. Now we are going to see the domain of fx is equal to tan x. Now this can be expressed as the ratio of sin x and cos x. Now guys, see that if this function is defined, this denominator cannot be 0. Now if this function is defined, the denominator cannot be 0, or we can say that cos x should not be equal to 0. So what are the values of x for which cos x is equal to 0? The values of x are, first one is pi by 2, then 3 pi by 2, similarly 5 pi by 2, 7 pi by 2, and so on. So these are the possible values of x for which cos x is equal to 0. Now see, we can write this as odd integral multiples of pi by 2. We can write this pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 as odd integral multiples of pi by 2. Since even integral multiples will become the multiples of pi, just try to see. If I write 2 pi by 2, this will become pi only. But I have to see pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, like this. So this will be odd integral multiples of pi by 2. Now odd numbers are of the form 2n plus 1. Therefore this can be written as 2n plus 1 pi by 2. So the domain of this tan x will be all real numbers except 2n plus 1 times pi by 2, where n belongs to z. Right? So all the values are allowed except only those values where cos x is becoming 0. And what are the values where cos x is equal to 0? Pi by 2, 3 pi by 2, 5 pi by 2, or odd integral values of pi by 2. Now the next one is the reciprocal of tan x, which is cot x. Okay, sorry, I missed this part. What is the range of tan x? We know that tan x achieves all the values from -infinity to +infinity. So the range here will be r. Now why is the range is equal to r? That can be clear from graph only, but I'll try to explain. Okay. Now fx is equal to tan x can be written as fx is equal to sin x upon cos x. Now obviously this can be both positive or negative, but the thing is, are there any boundations on this value, or this can attain any values? Now see, when sin x is greater than cos x, it will have the values between 0 and 1. So in that case, tan x will be, sorry, if sin x is less than cos x, this ratio will be less than 1. Okay. If I am considering that both are positive, this ratio will lie between 0 and 1, while tan x will lie between 1 to infinity if sin x is greater than cos x. So it will attain all the values. These are only the cases of positive values. In case of negative values also, the similar case will happen. So we'll say that the range of tan x, fx is equal to tan x, is all real numbers. Now let's see fx is equal to cot x. Now fx is equal to cot x is the ratio of cosine of angle and the sine of angle. So this is nothing but cos x upon sin x. Now the basic condition here will be that sin x is not equal to 0. Now sin x is equal to 0 is only there for only specific cases where x is equal to n pi. Okay, this is integral multiples of pi, like sin pi, sin 0, sin minus pi, sin 2 pi, sin 3 pi. These are all 0. So at x is equal to n pi, sin x is becoming 0. So x is equal to n pi is not allowed. X is equal to n pi is not allowed for fx is equal to cot x. So we can say that its domain is all real numbers except n pi, where n belongs to integers, and its range will be all real numbers. Okay, so just see the symmetry that sin x and cos x, their domain was all real numbers, but the range is only in this fixed intervals, this bounded interval of length 2, which is -1 to +1, while fx is equal to tan x. Now this has boundations on the domain. This has boundations on the domain on the basis that the denominator cannot be equal to 0. Sin x upon cos x cannot be equal to 0. If it is equal to 0, this will become not defined. Therefore, I am skipping all these values. I am eliminating all these values. Similarly, in the case of cot x, I am eliminating all of these values. So let's see the fifth and the sixth function. Fx is equal to cosec x, and next is fx is equal to sec x. Then we can complete this chart, and then we can proceed to the questions. So the first one is fx is equal to cosec x. Now we know that the trigonometric ratio cosec theta is the reciprocal of sin theta. Therefore, fx is equal to cosec x can be written as 1 upon sin x. Now, the basic condition for this function to be valid, or the allowed values of x, are only those values where x is not equal to n pi. Because if x is equal to n pi, sin n pi will be equal to 0, and those are not the allowed values. So here x is not equal to n pi, since that will imply that sin x is equal to 0, which will imply that this function is not defined. Okay, so here x will not be equal to n pi, so therefore we can say that r minus n pi, n belongs to integers. And what will be the range, guys? R, all real numbers. No, the range is not all real numbers. Why? Let's see. Because this is the reciprocal of sin x. Now we know that sin x lies between -1 to +1. So this lies in only a small interval, -1 to +1. This does not have any values which are greater than 1 or less than -1. So sin x is never, or we can say that mod of sin x is never greater than 1. Now see this thing very carefully. Pay attention here. Since sin x, mod of sin x is never greater than 1, we can say that 1 upon mod of sin x is never less than 1. Now see the beauty here. 1 upon mod as sin x will be 1 upon mod sin x is cosec x, so this will be mod of cosec x. So mod of cosec x, which is 1 upon mod sin x, will never be less than 1. Example, I'll take for an example. Example, we know that sin x is never equal to 2 or 3. Therefore, cosec x will never be equal to 1 upon 2 or 1 upon 3. So all the values which are less than 1 or which are greater than -1 will not be included, since I am talking about the modulus. So all the values which are lying between -1 to +1 are not included here. So the range will be all real numbers except -1 to +1. So this is the range of fx is equal to cosec x, all real numbers except -1 to +1. Now guys, this is an interval, so beware of this. The next one is fx is equal to sec x, and this will be the last one. Now fx is equal to sec x will be similar to fx is equal to cot x. Fx is equal to tan x. Fx is equal to cosec x is similar to fx is equal to cot x. Why? Because the domains are same. Why are the domains same? Because in the reciprocal or in the denominator we are getting a sin x in both of these. Now in both of 3 and 6, tan x and sec x, we are getting a cos x in the denominator. So fx is equal to sec x is equal to nothing but 1 upon cos x. So here the basic condition is cos x is not equal to 0. So x is not equal to 2n plus 1 times pi by 2, which is same to fx is equal to tan x. So the domain here will be all real numbers except odd integral multiples of pi by 2, where n belongs to z. Now in the range, it will have a similar case of cosec x, since we know that sin x and both cos x have the range -1 to 1. So both cosec x and sec x will have their range except all the numbers lying between -1 to 1. So the range will just photocopy here. It will be r minus -1 to 1. Or we can write this range in the sum books. This range is also written like this, that the range is -infinity to -1 included union 1 to infinity. So this is the other way of writing this range. Okay, wait, it's difficult for me to bend. -1 union 1 to infinity, and this will be the same range for cosec x and secant x. So now you must be clear with all the domains and the range of these all trigonometric 6 trigonometric functions. Now guys, see, these are not the only trigonometric functions. These are the very simple trigonometric functions. The trigonometric functions can be like this: sin x into cosec x, that is a constant function. Okay, leave that alone. Sin x into tan x, that can be a trigonometric function, or sin x plus tan x, or it can be a mixture of transcendental and algebraic functions like sin x plus x. Now this is both the mixture of transcendental and algebraic functions, or sin x plus log x. These can be the functions. But right now, if you are aware of these functions and their domains and range, you can easily solve those problems.